And now, lots of fun ensues because we're going to write this in standard form, but you may notice it is not, well, it's in standard form, but we want to get it to the vertex form, and we're going to graph it. Oh my gosh, which means we're going to complete the square, and it's going to be so amazing. I love completing the square. So, let's see, I'm going to highlight some stuff. I notice right away that there's a y squared. So that tells me if it's going to open up and down or side to side. I also then am going to just highlight this, the 2y there. And then I'm going to see the rest. The x is not squared, which means in the ultimate equation, I need to get that to the other side. So I'm going to rewrite it like this. Y squared plus 2y. In a little while, I'm going to complete the square, which means I write a plus blank, because I have to do something to get the square completed. Equals, I'm going to move that 12x minus 23 to the other side. So minus 12x plus 23 minus 12x plus 23. But do you see this blank that I added? If I add a blank to one side, gotta add it to the other side. Now, I need to get it looking something like this. Y plus or minus something squared. So I look right here, and I see that's a 2. Now, in order to complete the square, I take half of that, so plus 1. Well, then if I have y plus 1, and I square it, what happens is I get y squared, and then y times 1, but then the other times 1 and y, so plus 2y in the middle, and then what do I get at the end? 1 squared, which is 1. So that means I added 1. So I have to add it to that side as well. So that means over here I get equals negative 12x plus 24. Hopefully something in your brain says, oh, negative 12 and 24. Ugh, yeah. Something nice comes out of that. So I can pull a negative 12 out of both of these things. And I get x minus 2. And over on this side I have y plus 1 all squared. Now I can find all of the things that I need to find. I know that it's going to open left. Now I know it's going to open left. My vertex is at 2, negative 1. So 2, negative 1, that's right here. I know it's opening to the left, so I look right here. I know that 4p equals negative 12, so p negative 3. So that means from this point right here, I'm going to count 3 to find my focus. So my focus is now, I went 3 to the left, so at negative 1, negative 1. So you could either count the negative 3 or just subtract the 3. And then, therefore, I'm going to add 3 and count the other way. So my, what do we call that? My directrix is at x equals 1, 2, 3, 5. 1, 2, 3, 4, 5, yep. Oh, that's a straight line. Then I come back and I'm like, focal width. What's my focal width? Well, my focal width is 12. So from my little focus, I go up 6. 1, 2, 3, 4, 5, 6. And down 6. 1, 2, 3, 4, 6. And then, there it is. Ah! What fun. Okay, let's try one more and then we'll stop this video. Find the equation in standard form for a parabola whose vertex is at negative 2, 5. So I'm just going to graph that. Negative 2, 5. 1, 2, 5. And its focus is at negative 2, 1. That means it's opening down. if it's opening down, I know it's going to be an x squared thing. Equals 4py minus something. Because it always, since it's in parentheses, it always starts with the minus. Okay, so it went down 1, 2, 3, 4. So my p is -4. So if this right here is 4p, I think it's going to be -16. Because I just counted the 4 down, right? Then I know that my vertex is at, oh, maybe we'll make that blue. My vertex is at -2, 5, so -2, 5. Ta-da! And I'm done. Like, I didn't even need to draw the whole picture. I could draw the whole picture. Let's see, 16, so it would go 8 each way. 1, 2, 3, 4, 5, 6, 7, 8. So that was just good practice. If you're like, what just happened? Take time to figure it out.